a new topic. First, it's about organic chemistry introduction. The definition of hydrocarbon. These definitions you have to learn. So what's the definition of a hydrocarbon? The compound which contain carbon and hydrogen only. So we call these compounds as hydrocarbon. And for these compounds, because they contain carbon and hydrogen only, and we call them as hydrocarbon. So maybe between the two carbon atoms, they may have a single bond. Maybe the two carbon atoms may have a double bond, and they may have a triple bond. So if they have a single bond, we call these type of hydrocarbons classified as alkane. If between the two carbon atoms there is a double bond within the chain, we call them as alkene. And if there is a triple bond, we call them as alkyne. So alkane, alkene, and alkyne are the three main classes of these hydrocarbons. Then if it's an alkane, the name should end at ane. If it's an alkene, the name should end at ene. And it's alkyne, the name should end at yne. The base of these hydrocarbon, because we name them according to the carbon atoms, so it depends on number of the carbon atoms. So we use a specific prefix for these number of the carbon atom. And the prefix, so maybe it may have one carbon, it may have two carbon, 3, 4, 5. So if it is having one carbon, then the prefix we use is meth. If there are two carbon, then the prefix will be eth. 3 carbon, it will be prop. 4 carbon, it will be but. 5 carbon, it will be pent. So if there is one carbon, it's meth, 2 eth, 3 is prop, 4 is but, and 5 is pent. And if 6 carbon atoms are there, 7, 8, 9, or 10. So hex, hept, oct, so these are the prefixes which we use for the following hydrocarbons. This is the same thing which you already took in O levels. You studied all this thing like the naming of the hydrocarbon. The introduction is the same. Then these hydrocarbons can be a straight chain, it can be a branched or a cyclic. A straight chain, what is the meaning of a straight chain? A straight chain means if the hydrocarbon, the chain is having only two ends, we call that as straight. If more than two ends, we call that as a branch. And if there is no end, then we call that as a cyclic. So example, if I draw CH3, CH2, CH2, CH3. So you can see in this example, it's having only two ends. Like this is a start and the other one is end, or right side is start and the left side is end. So it's having only two ends. That's why we call that as a straight chain hydrocarbon. But this hydrocarbon can be a branch. Say CH3, CH2, CH, CH2, CH3, and CH3. So when you check this hydrocarbon, you can see in this case, it's having different ends, like this is end A, B, and C. So three ends are there, or more than two ends are there. What we call that as a branched hydrocarbon. And if there is no end, so CH2, 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 and CH2. So in this hydrocarbon, you cannot identify the start or the end because there is no end here for this structure. So we call that as a cyclic hydrocarbon. So a hydrocarbon can be a straight chain, it can be a branch, or it can be a cyclic. Is it clear, this part? Then saturated and unsaturated hydrocarbon. What's the meaning of saturated hydrocarbon and unsaturated hydrocarbon? So saturated hydrocarbons, the term saturated hydrocarbon means it contains carbon single bonded with carbon throughout the chain. Like it's not like only one carbon single bond, it's throughout the chain. Only there's a carbon carbon single bond, we call them as saturated hydrocarbon. And unsaturated hydrocarbon, if there is a double bond between the two carbon atoms, so carbon double bonded with another carbon, we call that as unsaturated hydrocarbon. Now there are certain formulas, like for a hydrocarbon there are different formulas. We have molecular formula, structural formula, displayed formula, and skeletal formula. For hydrocarbon, it can be molecular formula, empirical formula, structural formula, displayed formula, skeletal formula. So what is the meaning of molecular formula? Molecular formula, the formula which represent the actual number of atoms present in the compound. It will show the actual number So if we represent the actual number of atoms present in a compound, we call that as molecular formula. I will give example for each formula, but first I'm writing the definitions. What is the empirical formula? Empirical formula represent the simplest ratio between the atoms present in a compound. So when we represent the formula which shows the simplest ratio between the atoms present in a compound, what we call this formula, we call that as empirical formula. Then what is a structural formula? The formula which shows a minimal detail structural formula, the formula which shows the minimal detail about the structure of the compound. I'll give example so you can identify easily from that example. And what is displayed formula? Displayed formula, the formula which show all the bonds or covalent bond present in the molecule. That's called a displayed. Like if you remember in O level, they used to ask like show all the bonds when you draw the structure. So they mean to show a displayed formula. The formula shows all the covalent bond present in the molecule. And what is a skeletal formula? Skeletal formula shows the simplest organic formula by removing the hydrogen. And it's just showing the formula which shows only the carbon skeleton and functional group. That's called skeletal formula. Now I'll give example of each so you will understand this easily. Example, if I write C4 and H10. So C4 and H10 is a molecular formula. Why it's a molecular formula? Because it shows the actual number of carbon and hydrogen atoms. Like how many carbon atoms are there? 4, and how many hydrogen atoms? 10. But when I take the simplest ratio of 4 and 10, that's 2:5. So 2:5, the simplest ratio between the atoms, that is empirical formula. What is structural formula? The formula which shows a minimal detail. Like example, if I show that C4H10, how it is arranged, I can write like CH3. I can write CH3, CH2, CH2, CH3. I did not show any bond between carbon and hydrogen. I show the minimal detail about the structure. Just wrote like there is CH3, then there is CH2, then CH2, and then CH3. So what we call this, we call that as a structural formula. Displayed formula, the formula which represent all of the bond. So when I show all of the bond present in a molecule, that is known as displayed formula. Then what about skeletal formula? The formula which represent the carbon skeleton and the functional group only. So how many carbon atoms are there? 4. So if 4 carbon atoms are there, we use zigzag lines. Like this is first carbon, second, third, and fourth. These ends, like this is showing this is 1 carbon, second, third, fourth. So this is called a skeletal formula. I just shows the skeleton, like it's like a skeleton of the molecule, or showing how many or how the carbon atoms are arranged. Is it clear? The 5 formulas, the molecular formula, which shows the actual number of atoms present in a compound, the empirical formula, which shows or represents the simplest ratio, the structural formula, which shows the minimal detail of the compound, the displayed formula, which shows all the bonds present in the compound, and skeletal formula only represent the carbon skeleton and the functional group. Here we have only carbon chain, that's why. But we always use a zigzag lines. It's not like 4 carbon I show like this. No, that's not the way to represent skeletal. Whenever you're showing zigzag, the first carbon, second, third, fourth. So like there is 1 carbon here, 1 carbon. So it is representing. We don't have to circle this just to show or represent. Is it clear? These formulas. I'll give more examples, but it should be clear that what is the meaning of these formulas. Any doubt in this part? Now we'll draw some structures, because in exam, like you have sometime in MCQs mostly, sometime you have a displayed formula and you have to draw the skeletal formula. Sometime you have a structural formula and you have to draw a displayed or skeletal formula. So example, the displayed formula is given. This is a displayed formula is given. Now the question is, write the molecular formula. The first one. What's the molecular formula of this compound? The molecular formula of the compound. What's the molecular formula of the compound? C7 and H16, that's right. So molecular formula C7 and H16. That's first thing. Now, what is the empirical formula of this compound? You have the molecular formula, now the empirical formula. What's the empirical formula of this compound? Seven and 16. So 7 and 16 are already in the simplest ratio. So you cannot further simplify. That's correct. So empirical formula will also be same. C6H16. Now we have to write structural formula. So how to show the structural formula of the compound? Look, structural formula shows minimal detail. Like there is CH3, like making them in a group to show the structural formula. This is one group, this is one. Then this is another group. Then this alone carbon is there. Because we don't need detail about the structure. It's like shows a minimal detail. So CH3, CH3 and CH3. So there are three CH3s are attached to carbon. So I can write CH3, then bracket and 3. Because I don't want to show detail. Then they are bonded with carbon. So I showed carbon. Then next to this carbon is CH2. So I will show CH2. Then next to this carbon is also CH2. So if there are two, so what I can do, I can put CH2 in a bracket 2. And next to that is CH3. So I can put CH3. Is it clear? The structural formula of this compound. The structural formula of the compound, is it clear? Because three CH3s are there. That's why I put CH3 bracket 3. Then next to that is carbon. So I put carbon. Next to that is CH2 and CH2. So instead of this 2, I like writing them again. I can write CH2 in a bracket 2. And then CH3 is there. So that's a structural formula which shows a minimal detail of the compound. Is it clear till now? Then I need a skeletal formula. Skeletal formula means I want to show only the carbon structure. Like I'm not bothered about hydrogen. So 1, 2, 3, 4, 5 carbon are there. First 5 carbons are there in a straight chain. So 1, 2, 3, 4, and 5. So there are 5 carbons. There are 5 carbons, so I showed that 5. But the second carbon is having a branch up and down. So there is one branch up and one branch down. So that is called a skeletal formula. Even I can show in this manner, like I can also draw a straight line as well from here. That's also correct, no difference. Is it clear, this skeletal formula of the compound? Now another example. Normally displayed formulas are there because displayed formulas are the simplest formula and it's easy to draw these displayed formulas. this, you can use the screen annotation to answer this question. Means you can use you can just draw the thing on the screen so I can also see whether you're drawing right or wrong. So use the screen annotation to answer these questions. Molecular and empirical formulas are relatively easy because you just have to count the carbon and the hydrogen. The first one, if I say, what's a molecular formula of this compound? What's a molecular formula of this compound? So C7H16, C7 and H16. That's a molecular formula. Then what is the empirical formula of the compound? That will also be C7 and H16. That's correct. What is the structural formula? Use the screen annotation to draw the structural formula of this compound. There's an icon on the screen when you check the setting, like a pen, that's screen annotation. If you click on this, you can draw on the screen. Use the screen annotation. When you show the detail, it should be according to the structure. Yeah, I know it's difficult to draw with mouse if you are using, but it's just try. It's not an issue like how it appeared. I just want to check an idea. Bara, the order actually, when you draw this, you change the order of this structure. Like you made CH3 bracket 3. That's right. Like there are 3 CH3s. But the thing is, look, the best way, if you want to draw, the best way, if you want to draw, first make a groups, like make them in group. Like this is one group, CH3. Okay. Then next to that is CH2. Then next to that is C, that's one group. CH3 as another group, and this is CH3 as another group. Then next to that is CH2 and then CH3. So I should make them in group, write them like first it is CH3. So I wrote CH3. Then it is CH2. So I wrote CH2. Then it is C, the carbon, and this carbon is bonded with, or I can make these two first, like CH3, put them in a bracket 2, and they are attached to carbon, and then CH2, and CH3. What is the reason? Because when you draw this, the skeletal formula should not show disturb the arrangement, like it should according to the displayed formula. So when you draw the skeletal formula should not change the structure of the molecule. Is it clear? Even I can draw like this. I can put C first and then CH3 afterward. So it will not make difference. And if I want to draw the skeletal formula, now draw the skeletal formula. Use a screen annotation. Draw the skeletal formula of this compound. You can draw at any space. It's not necessary you draw at this point. You can find any empty space and you can draw the structure. I want participation from everyone. Yeah, that's right. Correct. That's correct. Like skeletal, because there are 5 carbon, 1, 2, 3, 4, 5 carbon. Sorry, I drew 6. So there are 5 carbon, 1, 2, 3, 4, 5. And then 1 is up, 1 is down. So that's a skeletal formula of this compound. I want another example. What's the molecular formula of this compound? Yeah, C5 and H12. So C5 and H12. Empirical formula will also be same. That's C5 and H12. Now, what is the structural formula? I want you to draw the structural formula. Use the screen annotation to draw the structural formula. Yeah, CH3 bracket 4 and then C. And what is the skeletal formula? The skeletal formula. Uh, Bara, actually, what you did, you made 4 carbon. You can see this is 1, this is 2, 3, 4. But here we have 3 carbon. So what you will do, yeah, that's right. So the structural formula was CH3 in a bracket 4 and C, and skeletal formula was 1, 2, 3, 1 up, 1 down. Even you can make angle, that's okay. Even you make straight line, that's also correct. So these are the formulas which we use to represent these hydrocarbons. Now, naming the hydrocarbon. Before this naming, the functional groups. So the functional groups, these are some functional groups. You have to learn this table, the functional group. Like example, if we have a alkane, homologous series alkane, it means carbon-carbon single bond is there, the name should have ANE. If double bond is there, the name should end at ENE. If OH is there, if it is suffix means what is coming at the end, it's all. But if you use a prefix, then it will be hydroxy. If chlorine, bromine, iodine is there, then a prefix chloro, bromo, and iodo. Aldehyde, this is a new thing which you will study. Aldehyde means C double bonded with O and H. This group, its suffix is al and prefix is formal. Like if it normally we are using a suffix al. Ketone, if C double bonded with O is there, we'll discuss them all, but I'm going through the functional group. Then the name should have ONE. If carboxylic C double bonded with O and OH, then it will be oic acid. And if C double bonded with O and O, then we call that as OH. So we will discuss all of these groups and naming. In unit 1, you have alkane and alkenes. And in unit 2, you have alcohols, halogen alkane. You should know aldehyde and ketone, carboxylic acid and ester. But I will explain all in right now for both unit 1 and 2, the topics, like all these functional group I'll explain. And then we can just go through the topic in unit 2.